Rajarohan, and in this video I am going to explain about my capstone project of StatML subject mobile price prediction. As you can see my name, my problem statement is creating machine learning model to predict mobile prices based on the specifications, and the mobile price prediction project utilizes a dataset containing mobile price attributes including product ID, number of sales status, weight, resolution, PPI, CPU frequency, internal memory, RAM, rear camera, front camera, battery and thickness. And you can see this is my data set. As you can see, the product ID, price, which is a target variable, sale, weight, resolution, PPI, CPU core, CPU frequency, internal memory, RAM, rear camera, front camera, battery and thickness of the mobile. And these are the graphs between target variable and future, price and product, scatter plot, price and sale, between weight and price, between resolution and price, between PPI and price, CPU frequency versus price, internal memory versus price, rear camera versus price, RAM versus price, and front camera versus price, thickness versus price, battery versus price. These are the attributes which are used, which are features: product ID, sale, weight, resolution, PPI, CPU frequency, internal memory, RAM, rear camera, front camera, battery, thickness. And here are the features. Product ID, this is typically a unique identifier for each mobile phone in the dataset. It doesn't contribute directly to the price prediction but can help to track and identify specific devices. And these are all my features. And I implemented linear regression and support vector machine on my dataset, which is this. And what is linear regression? Linear regression is a supervised learning algorithm used for predicting a continuous target variable based on one or more input features. It is a parametric approach which takes a linear line equation, and suppose the line equation is y equal to mx plus b, and m is the slope of the line. We can say m and b are the weights of the equation in machine learning. Now you can see that this code, first line I imported numpy as np, and second line I imported pandas as pd. In third line I imported matplotlib dot plot pyplot as plt, and in fourth line I imported train test split, and fifth line I imported nmax scalar. First of all, I am reading the data from csv file, which is I'm copying the path from here and pasting it. I'm reading the file, and next I am filling the null points as the mean of that column, and I'm dropping the price column and assigning all the other columns as features. As you can see here, price column, I'm dropping this column and making all these other columns as future, storing all them in a future variable, and taking that only price as a target variable. And I'm giving an array of strings, product ID, sale, and plotting every feature versus the target variable graph. And then I fitted the data features into the min-max scalar function and got the data min-max scaled, and I'm splitting the data into training and testing and applying linear regression manually, like as we know that formula, weights equal to weights equal to x into x transpose into x whole inverse into x transpose into y. I'm doing that here and taking the coefficients which are weights and coefficients. And I'm predicting x test from coefficient. I'm giving x test values in and as the features now, and I'm predicting, and now I'm printing the equation for the linear regression and plotting a scatter plot between y predicted and y test, and then I'm calculating error between y test and y predicted, and you can see the error here. And this is the best fit line between y test and y predicted, you can see here. And I'm taking inputs from users of every feature and giving that inputs in the equation. These are the coefficients took from the linear regression function which I declared over here. It is an array, coefficients array, and keeping these values in this function, and I'm predicting the phone price, as you can see here. As here I give every future as 1. And now as you can see the error, so linear regression, mean squared error 28,947, mean absolute error 139, root mean squared error 170, and best fit line for linear regression. And then I applied support vector machine to the data set. As you can see here, support vector machine is a supervised learning algorithm, and it is a parametric approach. It plots a line between it plots a line and find two lines. It takes a linear line which will go through the center and makes the line, and it will split the line into two like linearly and gradually increases the distance from the center. When it touches the top feature and bottom feature which are closest to the center line, it's the two parallel lines stops and plots the center line through those parallel lines, and we can do like that. From support vector machine we can do classification and regression. First of all, my project is regression, and here I done support vector machine. Here I imported libraries. As you can see, I imported min-max scaling, train test split, SVR. From an SVM I imported SVR, support vector regression, and matrices mean squared error, mean absolute error, the other reading, filling null values with mean, features, declaring features and target, min-max scaling, and train test split, and fitting the data into the function SVR, which is in sklearn.svm, and then finding the errors, mean squared error, mean absolute error, root mean square error, and then predicting y predicted values. Here predicting y predicted values and finding error between y test and y predicted, and then taking the inputs from the user and predicting the price like this. Here I gave all ones as future. I got 22, this 2232, and I got errors in SVM as mean squared error 5,98,064, mean absolute error 637, root mean square error 773, and thank you.